Now we'll talk about the velocity and acceleration in simple harmonic motion. After knowing that displacement is given by the equation x equal to a sine omega t plus phi. If you differentiate it with respect to time, it's going to be dx dt. A sine becomes cos when differentiated, so it will be cos omega t plus phi, and this would be differentiated again, giving you another term omega. A omega. So velocity you are getting a omega, a capital for amplitude, omega cos omega t plus phi. This is the relation for displacement. This is the relation for velocity. If you use the relation sine square theta plus cos square theta equal to 1, here you can write it x square upon a square, a capital, then v square upon a square, omega square. This is equal to 1. If you remember, this is the equation for ellipse, and the two axes, major and minor axis, are going to be x and v. So we could say confidently that velocity and displacement in simple harmonic motion are elliptically related. So naturally it's going to be a complex type of motion, because before that in mechanics we have gone through linear motion, motion along a curve, or you could say motion in a plane, then circular motion. They have their own characteristics. But this is a very complex type of motion in which you find x is variable, displacement, velocity is variable, v, and acceleration too is variable. That means here all the three parameters of mechanics, that is displacement, velocity and acceleration, all are variable with time and with distance both. So this becomes one more thing. If you want to plot a graph between velocity and displacement, this is going to be like this. Now further you want to just differentiate velocity in order to get acceleration. You will put dv dt, dv dt. This is going to be cos becomes sine and minus. Then when you differentiate this omega t plus phi, again you will get 1 omega. This is omega square a sine omega t plus phi, sine omega t plus phi. You see, this is the acceleration. You are seeing on the board the equations for displacement, velocity and acceleration. This I would write like acceleration alpha minus omega square a sine omega t plus phi. You compare all three, it is sine, it is cos, then again it is minus sine, minus sine. One basic thing that we could conclude here regarding the phase of all three I mean displacement, velocity and acceleration. Sine and cos have a phase difference of 90 degree. And once you say this is sine theta, this is minus sine theta, it simply means that they are having a phase difference of 180 degree. So we could say x and v have a phase difference of 90 degree, whereas x and alpha have a phase difference of 180 degree. You see the phase difference between displacement and velocity, this is 90 degree as I told you. Then phase difference between velocity and acceleration is again 90 degree. So overall the phase difference between displacement and acceleration is 180 degree. You know, sine theta is used for x and alpha. For alpha we use minus sine theta, as I told you just before few minutes. Here you can observe this x and alpha are exactly opposite to each other, means they can supplement each other. This is positive side, in the same time span you see it becomes negative. Only thing that you have to especially mention in your mind and retain it, that when x is 0, when displacement is 0, at that very time the velocity is maximum. And when the displacement is maximum, at that very time the velocity becomes 0. These two things you have to remember. In the mean position, the velocity is maximum. Whenever there is mean position, the velocity becomes maximum. This could be this side or that side. That means on either side, the velocity will be maximum in the mean position. And when this is extreme position, in that case you find velocity becomes 0. So, velocity and x 90 degree, velocity and acceleration 90 degree, x and alpha they have 180 degree phase difference.